Next person in the revised running order is Avanish Shrivastava.
First of all, thank you, Chair, for inviting me for this very important occasion. I must thank to the organizers, first Indo-UK Center for Environmental Research and Innovation, Aditya Birla Science and Technology Center, and Jawaharlal Nehru Advanced Research Development and Design Center. The topic which I have chosen, I thought it will suit to the topic of today's seminar. So I try to choose two topics which is going on, the work going on in the Advanced Materials and Process Research Institute where I am associated. I am also associated with National Metallurgical Laboratory, Jamshedpur at present. I have chosen two topics: electrodes from e-waste for efficient CO2 electrochemical reduction, and the second is red mud into eco-friendly radiation shielding materials and products. So far, we have been hearing about the policies and planning and the programs. Thanks to DST showing some slides of AMPRI also. So, because we have a large group working on waste to wealth. So, first topic is eco-friendly electrodes from e-waste for efficient CO2 electrochemical reduction. This work we have just started. And when I was discussing with Dr. Vilas Tathavatkar, he said, are you working on CO2 related thing? So I said, I'll club some of the slides. But keeping in my mind the 10 minutes constraint given by the organizers. So the electrochemical CO2 reduction is a promising method for CO2 utilization and also known as the electrolysis of CO2 to more reduce chemical species using electrical energy. So, electrochemical reduction of CO2 represents the conversion of CO2 to value-added organic compounds like formic acid, carbon monoxide, methane, ethylene, and ethanol. And the end product in above mentioned chemical depends on the selection of the metal, catalyst, and applied potential. Among them, for electrochemical reduction of CO2 to methane and ethanol is done in presence of copper in this. And copper as electrode for electrochemical CO2 reduction. It's known as electrocatalyst for electrochemical CO2 reduction as it is capable of electrochemically converting CO2 into more than 30 different products. More than 30 different products, including hydrocarbons and alcohols. Copper metal increases the CO demineralization process and hence facilitates the formation of C2 products. So copper from e-waste one can have discarded telecommunication lines, power lines, and industrial equipment such as electric motors, transformers consist of valuable and non-valuable metal copper covered by polyvinyl chloride. And now, like other metal, copper is 100% recyclable and retains its physical and chemical properties even when recycled, therefore recovering it from e-waste and revamping it for electronics and other energy and environmental related applications. We are mostly working on the agro waste, marble waste, and some industrial waste like red mud and fly ash. This is the new problem which we have taken up and we have started working on this to use e-waste as our working approach for eco-friendly electrodes for electrochemical reduction. We are collecting the copper wires, plates from electric cables which are known as waste for selective reduction of CO2 to ethanol. For this, we will also apply strategies where these copper wires will be further activated by a surface modification to achieve efficient conversion of CO2 with good Faradic efficiency. And we are very sure that these electrodes are economical and yet practically feasible current collectors for electrochemical CO2 reduction. So we are lab level workers. We go at the most up to the technology TRL 5 to 6, where industry can come and take the technology, and then we can join hands to work together to take the technology up to the market. In between, we file patents, publications, and we do HR development. So this was the first point. Second point is which is going on since last several years in AMPRI Bhopal. So AMPRI works on red mud, and it converts so far into radiation shielding materials of different products. First is X-ray shielding tiles, second X-ray shielding panels and doors, and the third is gamma ray shielding aggregates and concrete. Because of this time constraint, again I have cut down various slides, but I think I'll complete my presentation and satisfy your the kind of you are sitting here. So we have several patents in India and abroad in the field of X-ray, gamma, and neutron shielding. I will not go one by one, but these are very important patents. And based on these patents, we have transferred few technologies, which I will show you here, and good number of publications. People in academia, when they work and they publish, they think TRL is something else. That is not their domain. But I always try to convince them that whoever is doing research, even if basic of basic, they are somewhere TRL between 0 to 1. So they get encouraged. Because unless you do the basic research, you have a good foundation of research, you cannot have innovative technology. So that is very important. So whenever I am called for some expert lecture and youngsters are sitting who have done postdoc for several years and come back and start doing publications, I always encourage them like that you are also in TRL business, somewhere between 0 and 1. And so that is the foundation of any innovation. So can you imagine here the first paper which I am reflecting in Journal of Hazardous Materials, impact factor 14.22. This impact factor is more than nature communication. And this fellow has transferred technology to Prince Johnson. And now technology is in the market. So from 0 to 1 TRL, he is now TRL 9 somewhere. So red mud, most of, I think all of us know what is that. It's alumina industry waste. And when you convert bauxite into alumina, about 1.5 ton per ton of alumina, it comes out and it's highly alkaline. And it's millions of tons available. It's hazardous because of various reasons. First is very high alkalinity. But the good part which we have taken, which we have understood here is that it has very high content of iron oxide and titanium oxide suitable for radiation shielding. We have done the very precise and extensive exercise on the chemical understanding of this red mud collected from different sources. We have our own system. This is a well calibrated wavelength dispersive XRF, and we characterize these red mud and then further we utilize for our own purposes. Now even the basic researchers, coming back to that basis, even Science in 2020, there was a publication says red mud is piling up. Can scientists figure out what to do with it? This is the publication in 2020 in Science, where still we say that red mud TRL has gone very high. We have lots of solution about red mud to convert waste to wealth, but still basic researchers are also concerned about red mud. Some examples how red muds are piled up, and some cases are also happened. So the success stories of CSIR-AMPRI are the radiation shielding materials developed by AMPRI. First is diagnostic X-ray shielding tiles, where TRL we say now 8 to 9. Neutron and gamma ray shielding, TRL 4 about. Metal polymer composite for radiation shielding aprons, TRL 3. And radiation shielding doors and panels, TRL 4. And radiation shielding aggregates and concrete, TRL 6. So all these measurements we do at AERB, Atomic Energy Regulatory Board, because they are the people who can do that. Um, but these are the different TRLs. And I'll show you only one success story here, lead-free X-ray shielding tiles, which we transferred this technology to Messrs. Prism Johnson 2019. And you see, even after transferring technology, how much time it takes. The first installation we could do only in 2023. In between, we had done 298 sets of experiments. So that is where youngsters get frustrated. That no publication, no patent, only the experiment. So this kind of the ARB that measurements we do from ARB, and our material is there on ARB website also. That lead-free shielding materials have been developed by CSIR, Advanced Materials and Process Research Institute. These materials may also be used as biological shielding materials for construction of medical diagnostics X-ray installation, X-ray room. For further details of these materials, you may visit the website of ampri.res.in. So this was the technology we transferred, and we also received first time in last 40 years of AMPRI's history this NRDC award also. So there is a one video clipping, and after that my presentation will be done. So because anchor is watching her watch, so CSIR Advanced Materials and Process Research Institute, in short CSIR-AMPRI at Bhopal, has been working on the development of non-toxic and lead-free material to protect high-energy radiation shielding, which can be applicable from health to the strategic sectors. Mainly, CSIR-AMPRI's expertise lies on the conversion of industrial waste like red mud, fly ash, rice husk, brine sludge, etc. into radiation shielding materials by arresting their hazardous nature in a scientific manner. Billion tons of such noxious industrial waste have been piled up in the disposal plants worldwide and pose serious threat to the environment due to particulate emission, alkalinity, heavy metal leaching, etc. CSIR-AMPRI Bhopal had transferred a technology on lead-free X-ray shielding tiles to Messrs. Prism Johnson Limited on 10th June 2019 at Ansandhan Bhavan, New Delhi, in gracious presence of Dr. Shekhar C. Mande, Honorable Director General of Council of Scientific and Industrial Research, that is CSIR, and Secretary, Department of Scientific and Industrial Research, that is DSIR, to the Government of India. CSIR-AMPRI has developed this novel material using the industrial waste to shield X-rays that comes out of the diagnostic X-rays, computerized tomography, CT scanner, cath lab, etc. Nearly 6 mm thick material possesses the attenuation characteristics of 1 mm lead sheet. Since lead poses a serious environmental hazard, its usage is being discouraged world over. This technology is nearly 3 times cheaper than the lead, hence we use industrial waste as raw material. The radiation shielding material developed by CSIR-AMPRI Bhopal was accredited by Atomic Energy Regulatory Board, that is AERB of Government of India, and it has been reported as an alternative material of toxic lead to shielding high energy X-ray photons. Recently, Messrs. Saiji Healthcare and Research Private Limited, Ahmednagar, Maharashtra, has used CSIR-AMPRI's technology to cover the wall of their 3 X-ray diagnostic rooms, 1 CT scan room and 1 cath lab, and totally it's about 2,500 square feet. Tiles were utilized and it has been tested and approved by AERB. I am happy to say that joint-free X-ray shielding tiles are being made at pilot scale at Messrs. Prince Johnson in collaboration with CSIR-AMPRI Bhopal. On 13th March 2021, Dr. Harshvardhan ji, Honorable Union Minister Science and Technology, Health and Family Welfare, Earth Sciences, and Vice President of Council of Scientific and Industrial Research, inaugurated the Center for Advanced Radiation Shielding and Geopolymeric Materials. On this occasion, Shri Sudipto Saha, President Operation of Messrs. Prince Johnson, did mention that lead-free X-ray shielding red mud tiles, the product launch will be very soon, maybe within a month or so. Accordingly, we hope that our red mud radiation shielding tiles will be in market very soon. Thank you. Dhanyavad. Jai Hind. So this was a video clipping where the Prince Johnson said within a month, but then COVID came. But finally, a few months back, we have done first installation in Indian Navy, INS Kottawam. And I heard that today itself, I heard that they have got another order from Indian Navy itself for this lead-free X-ray shielding red mud tiles. This was also taken care as one of the 80 success stories of CSIR during Azadi Ka Amrit Mahotsav. After these 80 years of successful completion of CSIR by the Ministry of Science and Technology. So we are aligned with the Government of India missions like Make in India, Swachh Bharat, skill development, import substitute, and so on. And very recently, last year on September 7, 2022, we have also signed a MOU with Jawaharlal Nehru Aluminium Research Development and Design Center to work on certain aspects of this gamma ray shielding tiles under a project sponsored by Ministry of Mines. So with this, thank you very much. And we can collaborate, we can join hands. So the other side of the partner is empty. I have not written any name. So anybody is welcome to come to CSIR-AMPRI Bhopal. We are ready to join hands and work with our stable expertise and the facilities we have at the institute. And the collaboration is always welcomed at national level and global level to make the world go green. Thank you very much.